Welcome back. Again, I am your instructor, Ivan Brian Elindactivo, and we are currently discussing sampling procedures. So, the first part of our discussion was dedicated to census, and at the same time, the last portion was about us determining the non probability sampling. Born out of this question, that is there a necessity for us to randomize our participants, or what we mean giving equal chance to all the respondents or participants in a population or in a sample to be part of that study or to be part as actual participants or respondents? When we said that we don't need randomization, that is the moment we chose the non-probability. But when we said yes to this question, this is the moment we proceed to what we call probability sampling. Again, as a recap, this is a technique that uses randomization to make sure that every element in the population gets an equal chance to be selected as part of our sample. Okay? Which means, sir, do I need to compute for a sample size? Unless there's a preset sample that you need to gather, or let's say there's a mandated or a directed sample size given by your organization, your institution, the university, or the school, or a fixed sample size given for that specific study or research, then you don't have to compute. But nonetheless, if there are no preset sample size, again, there's a need for us to compute for the sample size. Not unless, as we have previously discussed, you can accommodate the entire population. But if not, then we have to resort to choosing or selecting, computing our sample size. So, how to compute for a sample or simply a sample size? There are several factors you need to consider in computing for sample size. The first factor will be the margin of error. When we talk about margin of error, it tells us about how many percentage points your results will differ from the real population. For example, you declare 1% margin of error. It talks about 1% difference from the actual parameter on the population. So it talks about your error. That's why we call it margin of error. It's a margin or a bracket of error, a plus or minus. Let's say you chose 5% margin of error, a plus or minus 5% from the actual population result. That will be your difference. So if we have, let's say, I am certain that the population has an average of 87%, then if your margin of error is 5%, that will be plus minus 87%. That will be a bracket from 82 to 92. So there's a 5% margin of error for that factor, which means correspondingly, it also has an inverse of the degree of reliability for the result. So if you have 10% margin of error, it means simply that uh, there's a chance, let's say for 100 respondents, a chance for 10 of that, you have a margin of error or error result or not reliable. Inversely speaking, that will be 90% reliability. And another factor is you need to understand is what we call the confidence interval. That every time you conduct that test, for example, you have a margin of error of 5%. Every time you conduct that test, you receive that margin of error of confidence interval of, let's say, you have a confidence interval of 95%. 95% of the time, or the value of that population, you will have that kind of error. So that's how much important the concept of margin of error is in taking up a sample size. Why am I discussing this? Because you need to decide how much margin of error can you take or is acceptable for your study. there's no such thing as absolute certainty when we talk about absolute. The margin of error gives you a leg room that most likely or closely you end up within this bracket. The smaller the margin of error, the higher the reliability of your study. The bigger the margin of error, of course, inversely speaking, the lesser your reliability. When we try to compute for the sample size, bear in mind that you need to consider how much acceptable margin of error you can accept or you can and consider it. So there are many sampling calculators out there or some sampling formula that you can use. But what is the most prevalent or let's say popular or widely used? I'll give you three in this presentation. Okay, so brace yourself. This is the first time I'll be showing you formula, but do not be overwhelmed with the formula because the legend is also here. And the first sampling formula that I'll be sharing is one among the popularly used in researches or studies or even in thesis and dissertation. This is by Slobin in 1960, or it's recited by Yamane 1967, or popularly known as Slobin or Slobin's formula. And here is the formula. The small letter n represents the sample size. The capital N represents the total population. And then E stands for the margin of error. By this time, I hope you were able to determine your margin of error. There's a computation for margin of error. Unfortunately, most of the times it has been the prerogative of the researcher or the institution. But what is the conventionally accepted margin of error? Usually, they fall under the bracket of 5% is the most popular or the most widely used uh, margin of error in most of the researches. And one here is a constant, which means the sample size will be computed as total population over one class total population multiplied to the margin of error squared. So if you have, let's say, total population of 2,000, let's say, you wanted to study um, students in a certain school, and the population of the students is 2,000 students, given the margin of error of, let's say, 5%, how much do I need to take as a sample size from the population? Okay? So given here, the population, let's say 2,000 divided by 1 plus the population again, 2,000 multiplied by your margin of error, with 5%, it will be converted into decimal value. It becomes 0.05. So zero point zero 0.05 squared, that will be equal to 332. Okay? So in the Slovin's formula, for a 2,000 population with a margin of error of 5%, you will be recommended to invite or say, take a sample size of 330. Okay? So that's one option. Second option will be the Coran's formula or under Coran 1963. The formula is also here. N sub 0, or the small letter n again, is the sample size. Again, E is the margin of error. Okay. By this time, I hope you already converted it into decimal value. Then Z is the C value found in the C table, and it's squared here. P represents the proportion. Yes, proportion. Example will be half of the population, so that's zero point 0.5. And Q is simply 1 minus P. So usually the z value here, you'll notice that in the z table, what is equivalent to most of the time, let's say it's 1.96, fixed value table. 1.96 squared times zero point 0.5 and zero point 0.5 for the proportion and zero point 0.05 for the margin of error. So that will surmount to 385. Okay. The 385 will be the ideal sample size for a study. based on the C table. Now, you will need to refer to the C table for this case in terms of your population. Okay? And the third, which is also becoming prevalent in most of the local or Philippine studies. If you see Calmorin's formula, you'll notice here it's a little, let's say, more extensive in comparison to the previous two. But it will also help you identify a more specific and detailed and more reliable, in a sense, sample size. So you need to consider first the total population, of course. Then there's the standard value or the V, capital V, which is 2.8. And this is in reference to the 99% reliability or 0.99 reliability. Then the sample error, most likely it's 0.01 or 1%, or the error margin of error that you're referring to, or we are referring to a while ago. And then P stands for the largest possible proportion, or let's say most likely they choose zero point 0.5 or half of the proportion, or 50.5. So the computation, as stipulated here, sample size is equals to n multiplied by b plus parenthetical the margin of error or the sampling error squared multiplied by 1 minus p over the, again, the population multiplied to the sampling error plus the value or the standard value of 2.58 multiplied by p multiplied by 1 minus p. Okay? I just did run through with the formula. But if you notice, out of the 500, let's say 500 population, how much is the sample size I need to gather or I will arrive at using the Calmorin's formula? 500, and considering, let's say, a proportion of zero point 0.5 and a sampling error, let's say, of 0.01, you will arrive at 193.57 sampling size. Sir, if that's the case, there's no such thing as a sample size or a number of participants that is 193.57 or N57. Wala naman po kalahati, sabi nga sa Tagalog. Which means you need to round this up. It's much better to round it up rather than uh, on the lower perspective. We need to round it up. It will become 194. So using Calmorin's formula, you will need to have a sample size of 194. Okay? So after choosing the formula appropriate for you, fitting for you, or your sampling formula that is appropriate for your study, and arriving at your sample size, now the next thing is to ask, given this sample size, let's say in Calmorin, you have 194, are these your direct participants or you still need to cluster them up? You need to divide them up or stratify them or distribute them to different, let's say, segments, sections, or portions, and then later on still subdivided further? Or are they the direct participants of your study? Which means you just need to extract them directly from the population. There are no other layers. So if this is the case, then they are your direct or immediate participants. So from the population, you just simply select them as your sample size. Okay? So how are you going to do that? Let's say you did the Slobin's formula, and out of the Slobin's formula, it uh, told you to have, let's say, a sample size of 24 participants. Now, and the 24 participants, as rather, I would say, out of the 24, let's say, population, Sloven's formula told you to extract or select 8 as your sample size. How are you going to extract this 8 or simply select this 8 from the total population? So the first non-probability sampling that you could, sorry, probability sampling that you could do will be simple random sampling. So when you say simple random sampling, you just simply select out of all the 24, you can pull them pull their names out of a box randomly. Simply use an Excel uh, program to type formula on random number 1 to 24, and then whatever numbers that comes up, you will be selecting the representative person or participant in that number. Okay, so until you arrive at 8 participants. So that's how you do simple random sampling. Okay, another way of doing this is to do a systematic random sampling. So when you say systematic random sampling, out of the 24, let's say, population, and you need to have a sample of 8, what you need to do is to divide the population out of the sample. So 24 divided by 8, that will give you 3. And this 3 will be your sequence. That every third of the population will serve as your respondent or participant in the sample. Okay? This will be involved in the sample. So let's say you have 24 divided by 8, that will be 3. So every third on the sequence will be selected as part of as part of the sample until you reach the end. Or bottom line, it will be still the same as the 8 target samples. Now, the third type of probability sampling will be what we call stratified random sampling. This is simply by doing the by dividing the population in groups or randomly selecting portions from each of the group. So when you say stratified, let's say I'll try to divide you according to the color of your shirt. These are not natural selection or natural division. And then out of these groups, I'll be taking 2 in each of the color of their clothes. For example, those who are wearing violet, wearing orange, wearing blue, and wearing shades of green. So I'll be taking 2 out of this. That will be stratified random sampling to arrive at the sample size of 8. Okay? And there's also a related random sampling to this. The fourth one will be the cluster random sampling. These are divisions or groups that are natural but not necessarily homogeneous. So, in terms of cluster random sampling, there's, for example, the cluster of those who are European and cluster coming from Asian, and then you can have equal selection from each of these cluster. So a natural clustering will be north, east, west, south schools or um, grade 7, grade 8, grade 9, grade 10 students. And out of that, you try to select your sample equally. So from these two groups, uh, the researcher could select 4 out of the first group and another 4 from the second. So that's class random sampling. So out of this, again, this probability sampling, we have the 4. Okay, the simplified or the simple random sampling, the systematic, the cluster, and the previous one, which is a stratified random sampling. So, uh, if you feel that there is a need to subdivide or further divide your participants in other groups or other sections or other segments. There are hierarchies or layers, and then you need to conduct sequence or several sampling procedures in each level. Then this is what we call a multi-stage sampling. And in a multi-stage sampling, you can incorporate the previous sampling procedures that we have discussed. You can incorporate probability sampling and non-probability sampling until you arrive at the direct participants of your study. So, for example, your study is about master teachers on their new normal education and teaching and learning styles. So, you wanted to look at master teachers. So, your multi-stage sampling might start on a national perspective or a regional perspective. Then that will be your first cluster sampling stage. Your stage one will entail cluster sampling. You will be taking up master teachers from every region. And out of every region, you will also equally take respondents or participants from every, let's say, division or provinces or city divisions. That's stage two of the cluster sampling. And then by the time you reach at the school level, you will be selecting not teachers, but instead, purposely, you will be selecting master teachers. So that will entail purposive sampling. That is for the stage three. And in each school, there are, let's say, several master teachers. So how many master teachers? Then you might, let's say, put the quota on it. Let's say in each school, I will only be selecting five master teachers. Then that will be quota sampling. And then in each school, you said I'll just handpick five of the master teachers, and yet they have, let's say, seven, 10. Then you can use simple random sampling. Okay? So this is an example of multi-stage sampling using both the probability and the non-probability sampling techniques. The bottom line here is for you to arrive at your direct participants. Okay? So these are the references for this lecture. I hope you were able to learn about sample sizes, sampling techniques, and procedures. And at the same time, I hope this lesson will aid you in your future endeavor in statistics and research. Thank you, and God bless everyone.